Hi everybody, I am Matthew Kocher. I'm the Director of Engineering for Cloud Foundry, so I run all the various Cloud Foundry engineering teams. We work out of the Pivotal office in San Francisco. Today I just wanted to give you an introduction to Cloud Foundry and really a technical introduction of how it works. So as an end user, Cloud Foundry is pretty magical, but behind the scenes it has to do a lot to actually make your apps appear without to do all that hard lifting for people. So I wanted to give you a little insight into how that works so that when we talk about Cloud Foundry, we talk about improvements, we talk about different components, you sort of know what's going on. After that, I'll give you a little preview of what's coming up for Cloud Foundry. The first sort of main component of Cloud Foundry is the runtime component. The runtime component is what's responsible for keeping instances of your applications running and scaling them up, scaling them down, serving HTTP traffic. The other components we have are the Bosh component, which is the deployment and configuration layer, and the services layer. Those are sort of separate. The runtime is really core. It's really about applications and application developers. It's the experience that really matters the most. Sort of when you get started with Cloud Foundry, you sort of have these developers. They're out in the world on the internet, and they have their computers, and the first thing they do is they go and install the CF gem. The CF gem is the command line interface for Cloud Foundry, and it's how you push an app to it. The CF gem, the command line interface isn't terribly useful by itself. What you actually need is an installation of Cloud Foundry. So the first component that we add is the Cloud Controller. The Cloud Controller is sort of the central brain of Cloud Foundry that keeps track of what the desired state of the world is. So it actually keeps track of all of your application code, your application versions, how many instances you want of an app running, and it's responsible for upgrading applications when you push new code to it. The Cloud Controller is a Sinatra app. It's written in Ruby, and it's horizontally scalable. It has a relational database backend. It'll talk to MySQL or Postgres, and the only other thing it needs is a blob store, so it can actually store files to go along with that. Once it has that, you've got a Cloud Controller. We normally deploy this at api.run.pivotal.io or whatever domain you're using. And you're set to go. You can start pushing your app. So you take the CF gem, and the first thing you actually need to do is log in. That's a component that I don't have pictured here, which is the UAA. The UAA is a Java Spring-based component, uses Spring Security to actually do all of the OAuth security that you sort of expect from any sort of platform of this level. You take that token, you give it to the Cloud Controller, and you say, create an application. The Cloud Controller creates the application, and then we're ready to start pushing the app. To push the app, the CF gem will actually tell the Cloud Controller, here are all the files that make up this application that are in the directory that you're pushing or in the WAR file that you're pushing up to the Cloud Controller. The Cloud Controller will then, it'll actually take the checksums of all those files, and it'll say, I have these files, I don't have these files, send me the difference. This way you end up with, you don't end up sending your entire application up to Cloud Foundry every time, you just send up the delta to Cloud Controller. The Cloud Controller then stores those in the blob store, and once it has received all the files, we're ready to get going and start deploying your app. The challenge we have here is that as a developer, you tend to only package the code that you need to run your application, your business logic in the application. You don't package all the libraries that you need to run your code in your source system. You don't package a runtime for the system. And so what we need to actually do is take your source bits and transform them into something that we can run on Cloud Foundry. We call this process staging, and we currently do it on a component that's called the DEA. The DEA is sort of our multi-purpose component that runs client code. So it runs untrusted code for us. So we use it to run applications, but we also use it for a process we call staging. Staging is where we take your code and we run a build pack on it. And what that build pack will do is look at your code, and if it's a Ruby app, it'll look and see, it'll download a copy of Bundler, it'll install all the Ruby gems, it'll download a Ruby interpreter, and it'll put that all in the directory. If it's a Java app, it won't do any of that. It'll take your code, your jar, and then it'll download a JRE and package that up with it. It'll also package some auto configuration libraries so that you don't have to know how to connect to various services in Cloud Foundry. By the end of this staging process, what we end up with is a tarball that we can untar on any DEA in the system. We can call the start script on that tarball, and it'll start serving your application and running. At this point, we don't care what framework your application is. All we care is that we can scale it, We can move it around. We can do anything you want with it. And we don't have to worry what runtime dependencies does your application have, because we package those all up into the droplet. We take that droplet, and the first thing we do is start uploading that droplet back to the cloud controller. Most applications, you're going to want to have more than one instance running. In fact, we recommend strongly against having one instance running, because then it involves downtime whenever we need to move it. So you're going to have 3 or 4, 8 instances of an application running. The DEA starts uploading your droplet back to the cloud controller, and at the same time, it starts one copy of your app right there on the same DEA. As soon as the rest of your application is uploaded, we will look for more DEAs that we can run your application on. It'll pick 4. It'll try and actually pick 4 that are not the same DEA, so that your app is running on 4 different instances at the same time, so that we have reliability in case of instance failure. And it'll send a message over the message bus and say, start up this application. Here's the URL. Here are the URLs I want to be accessible. I want to access the app at. So if it's hello.cloudfoundry.com, it'll map that, and it'll send that down to the DEA. The DEA will then start up the app, and it'll start running it. And this is great, except that when the app is running on a DEA, it's not terribly useful. What we need is another component to make it actually useful. We need to actually be able to route to this app. So for that, we'll need the last sort of component that we're going to have. We have end users for our application, and they've got their web browser, but they can't actually hit it. And what they need is a router. The router process is what's responsible for all incoming traffic into Cloud Foundry. It's currently written in Go, and it's basically an HTTP proxy layer. The benefit of our router is that it's extremely dynamically configurable. The router listens on the message bus, and as soon as it hears an advertisement for an application, it updates its routing table, and it knows how to forward application traffic to instances that are running that application. It'll listen on port 80, and it'll take application, it'll look at the host header, and it'll route it to any application in the system. The router doesn't have any state on disk. It simply, when it starts up, doesn't start answering requests until it's had long enough to overhear where all the applications are in the system and be able to route things. So the DEA will start telling it, you'll see we've got an arrow to the router, I'm running hello world, it's over here on this port, and you can get to it. The router will then forward the traffic to the right instance on the DEA. That DEA is running any number of warden containers, and it assigns a given port for that warden for each application, and the router knows which port to send it to. So this is sort of the basics of pushing an app to Cloud Foundry. It's a very high-level overview, but you sort of get the main components that you actually need to run a Cloud Foundry instance and be able to push apps to it. You need a router, you need a DEA, and you need a cloud controller. There's one more component that you actually need in the long run to keep your Cloud Foundry installation healthy, and that's the Health Manager. The Health Manager is a component that talks to the cloud controller and says, what do you actually want to be happening? And then it listens on the message bus and tries to ascertain what's actually happening out there in the world. Because as we know, working with computers, they're fallible, they tend to crash, it could just be a power failure, it could just be a software bug, but things don't always go right. We can't count that our code is going to get the system into a consistent state every time. We need a way to recover without having to have someone wake up and realize what's happened and fix the problem. So the Health Manager listens on the message bus, it talks to the cloud controller, and it say that you have a DEA that crashes. You would ask for 4 instances of an application. It notices there are only 3 running. The Health Manager then sends a request over to the cloud controller, says, it seems like you wanted 4, looks like there are only 3, you should check it out. The Health Manager, or the cloud controller, will then actually double check the Health Manager's work and start up the 4th instance of that application. The Health Manager also has all sorts of other edge cases. If a DEA has been unplugged for an hour and you've upgraded your application during that window, somebody plugs the DEA back in or brings the instance back up, it may be running an old version of the same application, so you may get up to the right instance count, but they may be running different versions of your application code. The Health Manager has to notice that and kill the old versions, start the new versions. These are all sort of, the goal of the Health Manager is to eventually bring the system to look exactly like the cloud controller says it does. So that's it really for what a Cloud Foundry installation looks like. For the runtime, there are all sorts of other components that sort of go into this. That we haven't really talked about, the UAA, there's log aggregation, but these are the core sort of pieces that you need to understand when you're pushing an app. So when you push an app and you see it start compiling and grabbing your assets, and then you see it uploading, you see it starting, and then you start mapping URLs, all of those things happen in these 4 components. The question that now arises is how do you get these all set up? And what we have for that is a tool called Bosh. Bosh is it's a low-level tool. It's complex, but it's extremely powerful. The goal of Bosh is to allow you to describe an entire cluster and declaratively say, give me this cluster. And then say, I want to change this one thing in the cluster. So if you have these 20 different virtual machines spun up, configured differently, if you say I want one more of one kind of virtual machine, it can launch that one virtual machine, configure it, put it into the pool. If you say you want 50 more, it can launch 50 more. It will, every time it does a deploy, it'll see what's actually out there, what you asked for, do a delta, and make the world what you asked for. It's extremely powerful. It's also infrastructure agnostic, so it will work across Amazon, vSphere, OpenStack, and there are other infrastructures that are always in the works being developed by various stakeholders who are interested in being able to deploy Cloud Foundry easily on their infrastructure. The third major component is Cloud Foundry services. We're going to have a whole talk on Cloud Foundry services, so I don't want to talk about them too much. But Cloud Foundry services are what let you take this stateless runtime layer and add state to it. So it's great to be able to push an app, but it doesn't work too well until you have some sort of stateful layer behind it. Usually that's a relational database, but it could be something like Redis, it could be Mongo, it could be Cassandra, it could be any one of these that you want to bind to your application. And Cloud Foundry services are the way that you can enable that and can connect applications to those persistent data stores and be able to provision them extremely easily. I want to talk one more sort of point I wanted to make of Cloud Foundry is we tend to talk about applications as sort of the unit of deployment. And in the Cloud Foundry context, we think of applications as one code base. A lot of times in larger environments, applications are many code bases. What we want to see people do is split large applications down into lots of small applications, then push them and have them communicate over an HTTP over the router. So you may be building some massive system, but you may actually, to build that one system, you may push 4, 5, 10 different Cloud Foundry apps and have them talk to each other over HTTP. We do this for our own internal systems when we need to talk about users. We go talk to the user system to get the users. We saw this, I think, with Cloud Credo when they published their blog post on Red Nose Day. They had all sorts of applications that were deployed on Cloud Foundry that made up the suite of applications that people talk to. A lot of small independent parts that you could easily upgrade, you can easily wrap your head around. And they're all easily scalable because they're all written with HTTP to access them. With a backend we can scale, and we know how to scale, and a runtime tier that we know how to scale. I wanted to spend a little time talking about how Cloud Foundry is developed. Cloud Foundry is currently developed in very tight collaboration with Pivotal Labs. Pivotal Labs was perhaps the namesake for the larger Go Pivotal organization that has sprung up here. And so we really do agile software development. We have a team of about 45 developers that are located in San Francisco, and we do test-driven development. We pair all the time, and we break up into small teams. Each team has a product manager who manages the backlog for the team, and we do all of our work open source on GitHub. So we have public access into those tracker backlogs. You can actually see what's happening. You can see that flow. You can see those commits that are going into the stories, being worked on by the team, being pushed up to GitHub, and then being deployed. We then tend to email out to the Cloud Foundry mailing list when we've actually deployed new features to run.pivotal.io. So it's extremely transparent, and it's extremely productive. We try and get things out start to finish very quickly. We try and deploy as quickly as we can and as regularly as we can. One sort of challenge this has is that our process doesn't tend to mean that we're on the mailing list all day. We're generally heads down, we're pairing with somebody, We're pairing with another developer and working on Cloud Foundry, the Cloud Foundry code base. So we actually have taken people out of the mix of the pairing and actually have them on GitHub, responding to people, interacting with the community, making sure that we're being responsive to everybody who's working on Cloud Foundry. And we're really committed to making that a better experience as things go forward. I wanted to next talk about what's in the pipeline for Cloud Foundry. This is probably the most exciting part for me. We've spent a lot of the last 6 months really refactoring the code base, really getting V2 out there deployed, burnt in, load tested, and running on Amazon. And we're now really hitting our stride and sort of pushing out new features, pushing out big changes, and we're really excited about it. So some of these have been announced and some of them haven't, so this is exciting. The first one we pushed out on this Friday at 6 p.m., which is the great time in the news cycle if you want to announce a project. We encountered a few difficulties actually getting it open sourced, but we are working on a new CLI for Cloud Foundry. So when I talked about the CF gem, we are working on an additional CLI that's written in Go. One of the strong pieces of feedback we've gotten from a lot of people who use Cloud Foundry that aren't Ruby developers is that they don't understand how to use Ruby gems. I think this is entirely fair because as a Ruby developer, I don't understand how to use Maven. But we don't want to make people go through the hassle of trying to deploy Ruby or downloading a large sort of omnibus installed version of the CF gem. And we were looking at seriously improving the experience using the gem. And when we sat down to do that, we sort of looked at the future of Cloud Foundry and said the best way to do this is to start from scratch and write it in Go. One of the benefits of Go is that you produce a single statically linked binary that you can take with you and put on any machine, well, of the given operating system. So there's one Linux binary, there's one Mac binary, and there's one Windows binary. They come from the same code base, and they don't have any dependencies. This is now open source on GitHub. It's still really rough, but you can get it. You can download it and check it out and play with it, and it's fun to play with, and you'll be hearing more about it in the future. The next thing that the teams are working on right now is a new services API. We've talked to one of the things we've found with Cloud Foundry is a lot of people are talking about writing services. We're writing services for all sorts of internal things within Pivotal, and we talk to people external, and they're really interested in integrating with legacy systems or integrating with their expensive relational databases, any sorts of sort of persistence layer that you may want, or even higher level services. There's all sorts of movement in the space, and the feedback we got was that it's really hard to write a service gateway, and you had to use our Ruby code. And we found that, well, we're happy with Ruby code. We don't want everybody to have to write things in Ruby. So we're taking I forget if we're calling it V2 or V3. It depends on how you count. And we're also changing the name to a service broker. One of the things that was confusing to people was that service gateways aren't actually proxying traffic to services. They're really brokering connections to a service. So as we go forward, expect to hear about how to write service brokers and see a lot of information about how to write your own service broker and having that API be nice and simple and easy and usable. Another piece of work that's coming up is eliminating single points of failure. Over the last 3 months, 6 months, we've done a lot of work classifying failure modes and making failure modes better. You can see this in the router, where if the router loses its connection to the message bus, it stops assuming that all of the apps have disappeared, and it just assumes that the world is exactly how it was when it stopped hearing about things. This sort of helps us recover in the face of an unreliable message bus. We've done the same things with DEAs and cloud controllers so that they're resilient to failures and come back up properly. But what we really want to start doing in the next few months is attacking the single points of failure head on and saying, why do we only have one health manager? Why do we have a message bus that only has one node? And getting away from that and saying, you can lose any node in the system and the system should still just work. The first salvo on this front is the new health manager. The health manager currently is a single point of failure. There's only one. If it goes away, your system stops healing. We knew we wanted to fix that, and we looked at the Health Manager codebase, and we knew we wanted it to be better. And so we spent the last probably 3 weeks really characterizing what the Health Manager does, writing integration tests around it that actually simulate the scenarios I was talking about, and making sure we know that we can recover from each one of those scenarios with our given Health Manager. And now what we're going to start doing, and I think they started writing some lines of code on Friday to prototype it out, but I haven't actually seen it yet. We're going to actually start on a fresh Health Manager, starting from scratch and written in Go. The goals of this are to make it a clean code base, make it easy to grok what it's doing, and also to make it so that it's horizontally scalable. So you can have as many Health Managers as you want. They'll deal with some sort of master election so that you only have one that's actually sending commands to the cloud controller, so that when you lose one instance, you don't start up n new copies of the app. But we're really excited to see how this goes. So that's all I have prepared, and I'm excited. I have a few minutes left over, so I get to tell you a story. The story I wanted to tell you about was our outage about, I think it was 3 weekends ago now. Amazon had a fairly large outage that took down parts of Instagram and other online services, and it took down a large portion of Cloud Foundry, run.pivotal.io, which is our hosted version of Cloud Foundry. We got a page, email went out, looks like Amazon's having issues, things are bad. Everybody responded, got in our Google Hangout that we use for production support, sort of started investigating, and it was all sort of the things that Amazon is known for. Amazon publishes a status update of, we're experiencing some instance failures in one availability zone. And you're like, well, that may be what you think you're experiencing, but we think it's a little bit worse. We had lost our NAT box, which is one of our known single points of failures in Cloud Foundry, and we lost some other instances that aren't single points of failure. And we spent probably about 20 minutes, half an hour assessing the situation, trying to figure out exactly what had happened, seeing what our options were. And then we actually decided that when Amazon was refusing to reboot our NAT instance, what we should do is use Bosh to deploy a new copy of Cloud Foundry to a different availability zone and bring up every user's application in the other availability zone. The first time somebody suggested this, I thought they were crazy. Our Cloud Foundry deployment is probably 70 VMs on Amazon. And it changes on a daily basis, depending on what components are out there, how many instances we've scaled up to. And so what we started doing was editing our Bosh manifest, changing the availability zone, changing the IP addresses, and about 20 minutes later, we actually had 2 people working on that, editing it in parallel so they could both see it. We hit Bosh deploy and watched Bosh spin up 70 new instances in the new availability zone. And we watched the application start coming back on our new instance of Cloud Foundry. All it needed was access to S3, the blob store, and access to the MySQL instance, which was replicated and still had access to. As these instances came up, they started running the applications that we had in the other availability zone. And after probably 40 minutes of watching Bosh do its thing, watching Amazon give us the instances as quickly as it could, which actually was surprisingly fast for an Amazon outage, we had an entirely new copy of Cloud Foundry deployed in another availability zone, and we could cut traffic over to it. And so an hour and a half later, we had completely redeployed our production system, cut traffic away entirely from the old system that was in some degraded state that we didn't actually know what it was, and have all the applications start being brought back by the Health Manager. This was really exciting to watch because it allows us to see the power of Bosh and really see what you can do when you actually have all of your servers managed under one tool. You don't have a single Snowflake server of the lot, and you have all of your applications deployed to Cloud Foundry. So they're all sitting in the blob store, they're all attached to their database services that are managed and redundant, and you can see it all just come back up and work. So it was really an exciting time for us, and it really allowed us to sort of showcase what Bosh can do when you're managing Cloud Foundry and what application developers can expect when they've deployed to Cloud Foundry, because none of the application developers had to respond to any incidents. As soon as we were able to get instances relaunched in Amazon, the applications came right back up and were rebalanced. So it was really exciting. That's all I have prepared today. So I want to thank everybody for coming. This is an amazing turnout. I'll be around the rest of the conference, so if you have any questions about Cloud Foundry, feel free to pull me aside and chat. Always happy to talk about this kind of stuff. So thank you very much.